Many of you may not have heard of the Putnam Mathematical Competition. It is probably the most difficult mathematical competition in the English-speaking world. Most of the questions are insanely difficult. However, the first question in the morning session is usually relatively easy. Here is one of them. You can pause the video now if you want to try it before seeing the full solution. First, I'm going to draw a vertical line passing through the intersection between the line y equals c and the curve y equals 2x minus 3x cubed, and I'm going to label the x-coordinate as b. Next, I will label the first shaded region as E, the second as F, and the blank region here as G, bounded by the vertical line x equals b. Now the first integral I'm going to consider is I1 equals to integral from 0 to b 2x minus 3x cubed dx. This is just integrating area under the curve of 2x minus 3x cubed, which also equals to f plus g. The second integral I'm going to consider is I2, which is equal to the integral from 0 to p c dx. This is just a rectangle which has area equals to E plus G. Now we are going to consider the equation I1 minus I2. Using the label we have just defined, I1 minus I2 is just F plus G minus E plus G. Since the G's cancel out, we are left with F minus E. However, E and F are the two shaded regions we want to make them equal. This is equivalent to saying F minus E equal to 0, which is also equivalent to saying I1 minus I2 equal to 0. Now we have the equation I1 minus I2 equal to 0. Putting back the integrals, we're saying that integral from 0 to b 2x minus 3x cubed dx minus integral from 0 to b c dx equal to 0. Since the lower limit and the upper limits are the same, we can combine these two integrals together. Integrating a polynomial is a very simple task, so this equals to x squared minus 3x to the 4 divided by 4 minus cx evaluating between 0 and b. Substituting the upper limit, we have 0 equals to b squared minus 3b to the 4th divided by 4 minus bc. The lower limit is just 0. There's a common factor of b which we can cancel, so we have 0 equals to b minus 3b cubed divided by 4 minus c. And now we have two unknowns and one equation, so we need a second relationship, which going back to the graph, we can see that the point b comma c is on the curve y equals 2x minus 3x cubed. So we have the additional relationship c equals to 2b minus 3b cubed. Now we have two equations with two unknowns, so we're going to substitute c into the first equation. We get 0 equal to b minus 3b cubed divided by 4 minus 2b minus 3b cubed. Collecting the like terms, we have b minus 2b, which is minus b. For the remaining two terms, we have 3b cubed as the common factor, so we can factor that out. What's left will be 1 minus 1 over 4. Hence, we have 0 equals minus b. 1 minus a quarter is 3/4 times 3 is 9, so 9/4 times b cubed. We can now cancel a copy of b, so we're left with 0 equals minus 1 plus 9/4 times b squared. Moving the minus 1 to the other side, multiply both sides by 4 nines, we have b squared equals 4 divided by 9, which implies b equals plus or minus 2/3. But we're working in the first quadrant, so we know that b must be positive 2/3. Using again the relationship that the point b comma c is on the curve y equals 2x minus 3x cubed, we can say that c equals to 2b minus 3b cubed, which means that c equals to 2 times 2/3 minus 3 times 2/3 to the third power. Therefore, c equals to 4 divided by 3 minus, a copy of 3 cancels out, so we have 8 divided by 9, which equals to, the common denominator is 9. We have 12 minus 8 divided by 9, which is 4 over 9. So now we know that the answer is C equals to 4 divided by 9.